we're coming back to this idea of key features in piecewise functions now, because there are some things that are a little bit new. A lot of these, all the definitions are the same. That's not what's new. But sometimes you'll see things in a graph that might confuse you a little bit, and what I'm really focusing on here is absolute max and min. Okay, I want to talk about those. Let's breeze through the early ones. Domain is just all the x's you can see. Okay, so that's -7 to infinity in this graph, right? -7 is where that hole is over there. And the range is -infinity to, looks like 10. And don't worry about whether, when you're looking at range, you're going up on this side of the function or that side of the function, right? It doesn't matter where in x you're looking. All that matters is what the maximum y value is anywhere in the function. And that's what you use. And if there's any gaps in y as you're going up, like let's say this weird piecewise thing, let's say it stopped there with a hole and then it picked up right here with a hole or something, you see that would leave a gap right here, which you would have to express in the range. But there are no gaps in this one. It just goes from -infinity up to 10. X-intercept is pretty obvious right there. Okay, that's 11, 0. Is there another one? Right? You might be thinking about this because it looks like it touches the x-intercept, but remember that's a hole, and holes are not intercepts. They're kind of like the opposite. It's a place where the function does not exist. The y-intercept is very obvious. Okay, 0, 5, right here. Okay, so now we're moving on to this absolute max, absolute min thing. And we've talked about local max and min. That's where there might be a local hill. Maybe it's not the highest hill anywhere, but it has a local peak. And if I were talking about local, that would be a good candidate right here. Okay, that would be a local max. And there would be another one over there. So you might have multiple local maximums. And actually, if we're going to get technical, so is this one right here. That's a local max. Because if you look at this point right here, to the left, to the right, either side of that point, nothing is bigger than it. So a flat line counts as a maximum. And flat lines kind of get complicated to deal with. So this one's not asking for local max. It wants to know absolute. And that means the highest value of y anywhere in the function, which is pretty clear, right? This is an obvious one. Once you know what you're talking about, right? Absolute value or absolute max. So this is going to be a maximum value of what? It's not a coordinate point. We don't say 6, 10 as a coordinate. That's a location, not a maximum. This maximum is 10 at a location of x equals 6. That's the way you write maximum. Now, minimum. Let's talk about that. What's the absolute minimum? Well, here's a relative minimum, a local minimum, because if you look either left or right from that dot, nothing is lower than it. So that means that's a minimum. But it's a local. And I'm not talking about locals. I want to know absolute, because this value is lower than that other one to the left. So I know this is not the absolute value or absolute minimum. But if you look at that point I just drew over here, there's something lower than it right here. And there's something lower than that right here and that, and so on until you get to infinity, which you never really do. So there is no local minimum, or there's no absolute minimum. There's always something lower. Even if I said -1,000,000, you could just say -1,000,001. Okay, so it does not exist. That's how you would answer that one. And then increasing, decreasing, we've talked about these before, right? We're just looking for all places where it's uphill. So this goes from -7 to what looks like -4. Okay, that's this section, which is uphill. And then I've got another uphill section right here, going from 1 until 6. Okay, decreasing is going to be -4 until I get to -2. Union, looks like 6 is where it picks up going downhill again to infinity. And constant, I think we all know what the level part of this graph is, right? That's going to go from -2 to +1. And if you notice, I've used curvy parentheses for all of these. There's no square brackets, because when you talk about increasing, decreasing, and you ask yourself, well, here, let's pick on this point right here, okay? If I said constant were -2 to 1 with square brackets, what that means is that point that I've drawn at x equals 1 is constant. But we can see it's not, because if you look to the right of that point, it's higher than the point itself. So that's not a constant value there, and nor is it increasing, because if you look to the left, it's level. So that's why we use these curvy parentheses here. We don't include the points where something is changing. Positive is pretty much everything, which I'm going to say is -7 all the way through 11. And negative, I guess you could say, is even more of everything, because that goes to infinity. Just remember, when you're doing positive and negative, although you are looking at y values, you still have to put x locations, because we are in interval notation. Okay? You always use x locations in interval notation. The only exception to that rule is this guy, range, because you literally are asked for what the y values are. In every other case, you use x values.